function, modifiers, right? Now we're going to be looking at, so far we have seen the use of functions. In our practical class of yesterday, the one of last week Thursday, we saw function, how function are written. So by now, I believe we should all have a overview of function itself. We'll also be looking at modifiers and also be looking at immutability. Right. Yeah. Okay. So just a moment. Let me just check. Okay then. So to begin today's class, we'll be taking 4 objectives. We'll be looking at function types, the types of function that we have. We'll be looking at visibility modifiers. We'll also look at custom modifiers, and then we'll look at immutability and constants. All right. So now these are used in constant and immutability are used in variables. So we'll be looking at this for. So the first thing is function. So far we have seen the graphical representation of function, but in terms of theory, when asked what is a function, we need to understand that a function is a block of reusable code that can be called from anywhere within a smart contract. Now, it's the fact that it's a block that is a combination of different lines of code. Now, note your function could be a line, one line, it could be multiple lines, but your function can be reusable. So wherever you can call your function in multiple places, multiple times, depending on the visibility and other factors. Now, this kills the need to rewrite the same lines of code multiple times. Now, when we are writing your smart contract, in scenarios where you need the same line of code in multiple places, you don't need to write it multiple times in different locations. All you just need to do is to write a function, and without function, you don't need to repeat those lines of code again. You just call your function wherever you need that functionality. In Solidity, functions enable developers to read, write, modify, and store data. Now, when we're talking about write, we're talking about making calls, probably to change something. Now, to read, write, modify, and store data, all of these functions allow us to do that. Now, they also provide a way to interact with the contract by externally owned accounts and other contracts. So far, in our practical classes, we have seen how functions have allowed us to interact with our wallets, right? And also different, our externally owned accounts, functions provide a way to interact with them. So this is the theoretical part of function, and we should take note of this. Now, what are function signatures? The function signature consists of the function name and the list of parameter types enclosed in parentheses. Now, I believe in the function where we have written so far, we have seen cases where we write the name of the function, and then inside of a bracket, we put in different parameters where with that are typed like with their types and stuff. Now, all of that all makes up the function signature. Now, with the function signature, you can have 2 functions with the same names. Those of us coming from different backgrounds, probably from JavaScript, we would know that you cannot write function with you cannot write 2 functions with the same name. It won't allow you. But in Solidity, making use of function signatures, you can have 2 functions with the same name, but then the signatures must be different. What do we mean? If you want to name your function get balance, you can actually name 2 functions get balance. But in terms of your parameters, what you pass into the bracket, the parentheses, it has to be different. So this is where function signature comes in. Now, We would look at the practical aspects later on after this. We now have the function selector. Now, to understand the function selector, it is the first 4 bytes of the KECAC 256 of a function signature. Now, remember in the previous slide, we talked about function signature. What the function selector does is that is a sorry. So what it does is that it helps to determine which function to call when multiple parts are present in a contract. So making use of this function selector, in a scenario where you have different functions with the same name, this function selector helps to determine which function to call. And it is the first 4 bytes of the hash of the signature, function signature. So we're going to be looking at how it looks like. And we'll also take, in our practical class, we'll take a look at that. So we'll come back to this. Now, the next, we'll be looking at visibility modifiers. Now, when we talk about visibility modifier, they are used to determine the scope of visibility of a state variable or a function. Now, please note of a state variable or a function. It specifies from where the state variable or function can be accessed and used. For state variables, we have private, we have public, we have internal. All states are internal by default. So if you don't provide a visibility modifier, by default it's going to be internal. Meanwhile, functions all have all these three, in addition of external. So when you are trying to specify your visibility for your function, you have 4 options. You have your private, you have your public, you have your internal, you have your external. While variables have 3, which are your public, private, and internal. In terms of internal visibility, it allows access only within the same contract or is derived contract. So when you define a variable or a function as an internal visibility modifier, now what it does is that that state variable or function can only be accessed within the contract. So within your contract level, or if the contract is derived, you can access it from its derived contract. That's internal for you. Now, when we talk about external, enables interactions with external accounts.
Excuse me, King. We can't see your screen from here. You stop sharing your screen.
Okay, I think my network is up. Okay, please, can you see it now?
Yes.
All right. We talked about internal, where you said internal visibility only allows access within the same contract. Now, in terms of external, it enables interactions with external accounts or other contracts, but they cannot be invoked within the smart contract or its child class. So you can only make use of it externally. Within the same contract, you can't make use of it. So we would take a practical look at this when we reach the practical aspects. Now, in terms of public visibility, it allows access both internally and externally. Now, when we
Sorry, we lost you again. Hello, King, are you there? Okay, I'm very sorry. Let's give our tutor 2 3 minutes.
Yeah, hello, can you hear me?
Yes, we can hear you all right.
All right. Sorry about that. My network keeps cutting me off. Okay, so to continue from where we stopped, for private visibility, it's quite similar to internal, but the difference is it cannot be accessed from no for internal we said it can be accessed in its derived class, but in terms of private, it cannot be accessed in its derived class. It can only be accessed within the contract where it is defined. So this means the function cannot be accessed from outside of the class or contract, including any derived classes or contracts. So that's the difference between internal and private. Now, we would also look at pure and view functions. A pure function promises not to read or modify the state variables, whereas a view function can read but not modify the states. All right. In terms of custom modifiers, you need to understand that custom modifiers are a powerful feature that allows developers to write usable code blocks that can modify the behavior of functions. They can be used for access control and so on. So in terms of custom modifiers, it can be used for checks, like your conditional checks. It can be used to just give access to probably the owner of the contract or some certain user types that have certain permissions. So for custom modifiers, they're widely used in smart contracts. And most times they are used to write reusable code, so you don't need to keep repeating yourself. Now we also have constant and immutable state variables. Now for state variables declared as immutable in Solidity, cannot be modified after their initialization. That is, you give it a value, and once the contract is being initialized, you cannot change that value again. We also have constants. So constants have fixed values and cannot be changed during contract execution. They are used to hold values that remain constant throughout the contract's lifespan. So once you deploy the contract, once it's compiled, the they are going to have a fixed value that is going to just be a singular value, and they cannot be changed during the contract execution. Now, these are all we'll be looking at today. So what we'll be doing now is we are going to be taking a deeper look into the practical aspect of things. Now, the first thing we talked about, if we can remember, is function. And then we talked about function signatures, where two functions can have same name, but the signatures must be different. Now we'll be looking at we'll be looking at the practical aspect of that. Yeah. Okay. Okay, so to take the practical aspect, our moderator and team lead, Mr. Oracle, is going to lead us through that aspect.
Yeah, GM, everyone. Yeah, so I'll be sharing my screen now so that we can move on to the coding parts. Can you see my screen? You can see my screen. Please send an emoji. If you can see my screen, please send an emoji. Okay, thank you very much. So let's go. Let's get our boilerplates. Okay. Just delete this. Get. Okay, so this is what we'll be doing this morning. We'll be creating a very simple function. So the function is going to be called simple. So this is a function, and you can see that I'm going to make it a public function. So it works. Then also for function overloading, you can also have something like this, which is address. Let's just give it anything. Then you can see that it's still okay. Let's make it public. You can see that this function, both of them works perfectly. There is no error, although they have the same name. But because they have the different function signature, they they still work. So that's it. And that's one thing about this function. So you can have this two functions with the same name. So far they have different function signature. So let's now create another one again and see whether we can also have something like that. Let's create it. Let's say ABC public. You can see that we're able to overload one more time. Although they have the same number of parameters, which is 1, 1, but because they have different type, parameter type, so you can still overload like that. So another thing again is if you try to do something like this simple address, then give it BCD public, then say it's going to throw error because to the compiler, these two functions are the same because their function signature is the same, simple address and also some simple address. So you can overload it and maybe add one more stuff. You can have A, V, D. So all these functions are different functions to the compiler, so there won't be any error. So that's what we call function overloading. And since they all have the same they all have the same function names, but different function signature, they can work perfectly. So if you have any question, please you can unmute and ask.
Okay, please can you zoom in further?
Okay, I've done that. Okay, let's move to the next thing. And this is what I want to do this morning. We want to create something very simple using everything that we've learned so far. So we also have something called a modifier, and we have this public is called a visibility modifier. So for other modifiers can have something like private, can have um, internal, can have external. So all these functions, they mean different stuff to the compiler. And you can see that if you have a public function, and also you can also have an external function. So this external, if let me show you something. Let's make this one external, this one internal. Then let's make this one private, and let's make this one external private, and let's make this one public. So now if you deploy this function, if you deploy the smart contract now, you will see that only the external and the public will be visible outside the smart contract because external and public are visible uh, outside the smart contract. So this is what we want to do now. Let's deploy. The moment we deploy, we have this new contract. Why is it not toggling? I think my system is okay. Okay, so we have two functions. One is simple, which is this one, the one on line 13, and we also have the one on line 7, the one without the parameter, and they both work perfectly. And the reason is because they are all external and public. So now what's now the difference between external and public? Let's try to do something now. So if you have this external here now, you have external and you have public. What's the difference between the two of them? Although they are visible outside. you cannot use external inside the smart contract. If I try to say something like simple, it's going to throw error. You see that there's an error because it's no matching declaration found. So that's the error it's throwing, and that's because this simple here is only visible outside the smart contract because it is external. But if I do something like simple, let me just get a simple zero address. Let me just say address 0, then comma, we have the 10. So basically, we are calling this contract, this function on line 15. So it works because it is public and it is visible outside and inside the smart contract. The same thing with private. You can call private like this, simple, and do something like simple 1. You can see that it's still working. We are calling the function on line 14, then so on and so forth. Let me try to do one more thing so that we can understand. Let's assume we have two functions. One is called get balance, which is going to be public, so anyone outside can call it. Then let's say we have another one called, let's give it set balance. So this set balance is private. Let's just give it private visibility. Then we also have another one called let's have another one called do something. So this do something is going to be internal. Then we also have another one called do everything. This do everything is, let me just say do. So do. Let's name this one do and give it the external visibility. So we have these three functions. They have different names, but different and also different visibility too. If you try to call do inside get balance, you are going to get error because do is meant to be called outside the smart contract. It's not meant to be called from inside the smart contract. That's why it is throwing error. Now let's do set balance. If you call set balance anywhere inside the smart contract, it's still going to work. Can you see it's going to work? No error. You can call set balance anywhere, it's going to work. The same with do something, it's going to work because of the visibility. So the visibility matters a lot and it determines where your functions and states are visible from. Another thing you have to know again is that although we now know the difference between public and external, what is the difference between private and internal? Private and internal, although they can only be visible inside the smart contract, but private is more strict. Let's do something. Don't worry about the syntax, but we will still be doing that later on. But I just want to show you the difference so that when we get there, it won't look strange. Let's have function example child, which is the child of this contract. So we say function example child is this function example. This is just a very simple syntax. Don't worry, we'll still talk about the syntax later on. And let's create a function, a very simple function. Let's name it do. So this is the name of the function, and it's an external function. Let's try to now call all these method or function from this child contract. One thing you have to note again is that by saying that this function example child is function example, you are literally inheriting everything inside this contract. So inside this contract now, we are having how many functions inside this function example child? We are having 5 functions, but because of the visibility, some of those functions will not work. So that's what it means to inherit. So by doing function example child is function example, we are inheriting everything inside this function example contract. So that's how it works basically. So now let's move to the next thing and let's try to call do something. If you try to call do something from here now, it's going to work. It's going to work. There won't be any error at all, any warning. If you try to do set balance, I mentioned something that this internal and private, they are different. This is where you get to see the difference. You see that this set balance is not going to work because it is private and it is only visible from um, this contract. It's only visible from this contract. If from this contract, it is not visible from here because it is private. Then we can move forward again and say get balance. If you have something and you have it, let's say get balance, because this get balance is public. You can access it from here. But if you try to do something like do here, it's going to throw error, which is because it is external. So that's the difference between the two visibility, internal and private. Private is private. It is not, you cannot inherit it. It's not going to allow you to do that basically. But internal is going to be inherited, but it will not be visible outside the smart contract. So that's how it works basically. I hope I've been able to explain that very well. Then also we have, I've explained that one already in our previous class. We have view and pure function. Pure function and view function, they are all about modifying and reading state. If a function is pure, if a function is pure, it's that means this function is not modifying any data and it's also not reading any data. That means it is self-sufficient. It's like saying, oh, I'm self-sufficient and I can undo myself alone. So we have function and say add. This add function, what does is it takes two parameters. So a comma, then int 256 b, then it is a public function, that it is a pure function. And what it does is that it returns, so it's going to return, right? So we have to have returns. What it's going to return? It's going to return uint 256. Then you can say return a plus b. This function is a pure function because everything that it needs is being passed to it. It's not using global state and it's not reading from any state variable. So it is just self-sufficient. It is self-sufficient, self-confined, and it is enough to just process everything it needs by itself. But look at this function now. This function is different. What it does is that it's going to take, let's have a state variable. Let's name it uint c. So this function is named, let me say, sum or something. Yeah, let's name it sum. And what this sum does is that it returns this particular value. Let me say a. Then can have public, can have view. Then returns. It's going to return uint 256. Then what it does is that it returns this a plus c. It's a view function because you see that it's not modifying anything. It's just returning values. It's not modifying any state variable. It's only working on its own. But actually, it can modify stuff inside itself like this. You can see that there can be some manipulations there. Maybe like d is equal to a plus c. You can see that it's going to return d. Now it's still a view function, and the reason is because it's not modifying any state variable. It's not changing the value of this c. You can see that the value of c will always be the same after running this function, and that's why it is a view function. But for this pure function, it's not reading anything at all, and also not modifying anything. So let's prove it. The moment to have c in these our contracts now is going to start completing. You can see that function declared as pure, but it reads from environment state and does require view. So that's the error you'll be getting, and that's the difference between pure and view. So all these things we had after the function, they are just there to tell you more about the function. So I'm going to write a very simple function now on screen, and I will want someone physically to tell us what this function is all about. Let's have a function called arc, arc, arc. This function is very confused, but don't worry. I'm going to make it very long and a bit scary, but don't worry. It sounds very simple. Let it be private. So can someone describe this function from what's this? Okay, this is an error. Sorry. Okay, we have C already, so we have to remove it. Sorry. So can someone describe this function? Let me try to zoom in. Can someone join us physically describe this function?
On. Can you hear me?
Can join us physically, please? Can you? Okay, yeah, I can hear you.
Yeah, my name is Jami. The function arc, yes, the function arc, it says that it has a U256 by 32 and by 1C. So the function say that it should return only by 32. So that's what the function is all about.
Okay, that's awesome. Thank you very much for that. What about the visibility and also the immutability of the function?
Okay, yeah, number one, it's private, and
Okay.
the view means it is dependent. So it doesn't require any external code. So since it is view, it is not pure.
Like, what does that view mean? What does it mean?
Yeah, it means that it is self-sufficient. So it doesn't require any external variable.
No. View is not self-sufficient. It's going to read from the state variable, but it's not going to modify it. That's what makes it view. But pure is not going to read and it's not going to modify from the state variable, global variable. So that's what makes it pure. So that's just the difference between the two. Do you get? Yeah. Okay. Thank you very much. So let's continue what we're doing. And one thing again is that you can also have your own custom modifier. So what the custom modifier does is that it allows you to change the behavior of a function. So there are two parts. There's one that will run before the function and one that will run after the function. So this is it. This is what we have. Function. Let's give it arc. So this function is public. It is it's not a view function basically. It's going to modify something, but it's going to also do one. It's going to return. Let's say returns. Let's not have any return, but let's just say this. Let's now have a custom modifier. To declare a custom modifier, this is what you do. You just have this modifier, then the name of the modifier. Let's say the name of this modifier is
So please, can you
double,
zoom in?
okay. The name of this
Okay,
custom
and
modifier is double me. Can you see my screen now? Oh, sorry.
yes, we
Hello.
can see it.
Okay, so
Yes, we
now
can see it.
you notice there is a difference between function and modifier. Modifier is just you use the keyword modifier followed by the identifier of the modifier, the round brackets, then the curly braces. But inside the modifier, you have to have something like this, like a separator. This underscore and semicolon. That's what we call a modifier. Sorry, it's like a separator. Yeah, basically, it separates what will run before the function and after the function. So everything here will run before the function, before, then everything here will run after. Do you get? After the function. So now if you apply this modifier to this function now, like double me, so if you apply it now, it's going to modify the way this function behaves. You can see that this function does not do anything. It does not do anything basically. What it does is just there looking But let's say we have a state variable like this called a, and by default a is 5. Then once you have a is 5 like this, you can have a function that does one thing for us. function get a, which is going to be a public view returns uin 256, then we can say return a. So this is a function that gets a for us. And if you notice that inside this arc, there is nothing inside, it's just empty. But before the function runs, what we want to do, I want to double a. You can say a is equal to a times 5. Or let's say a times 2. Or a is equal to this instead of using. So it's going to double a, and we can prove that by deploying the smart contract, because this is going to run before the function and this is going to run after the function. So let's do that and let's see what we have. This is a function here. Let's delete this. Let's now deploy again. We have our function. You can see that the only thing we have is arc, and get a. If we click on get a, what we have is 5. And let's click on arc. The moment we click on arc, we have a message that is successful. If you click on get a, now it's now 10. So this modifier allows us to modify the behavior of this function. So this is very useful for a lot of applications. You can use it as an access control. Like maybe you want to throw an error here now. There's a way you can throw error. You can say revert or stuff like that. So if you say revert, now this revert is going to throw an error. So it's going to throw an error, and if you deploy this contract now, it's going to throw an error inside this block of code. So let's try that, and let's try to do something like that, and let's see what we have. Deploy. The moment we deploy, you can see that we have these two functions again, arc. So when you click on arc, you can see that we have what error. It is reverting. So that's just what modifier is all about. It modifies the behavior of a function. And don't worry, we still talk more on modifiers later, but this is the syntax to declare a modifier. You know that this part will run before the function and this part will run after. So you can also come here and say maybe after this you want to revert or do something. It's going to still run. So that's how it works. Before and this before, this after. Before, after. So after the function. So you can apply this modifier to as many functions as you want. So it's going to just change the behavior of the function. And we are still going to use it tomorrow in our class. But before that, I want to teach you one simple trick, which is we don't need this getter function again. What we can do is you can just make this state variable public. If you make this thing public now, you don't need a getter function again for it. It's automatically going to give us a getter function. So let me remove all this stuff. You can see I've removed every code except this line 7. So let me try to redeploy. Let me deploy again, and we come. You can see that we have a button for A alone. And when I click it, I get 5. So by adding public to a state variable, you're automatically exposing that state variable to the outside world. So anyone can automatically just interact with it and get the value by clicking on the button. That's how it works. But if you don't make it, if you don't add any visibility modifier, it's going to be internal by default. There is internal, there is private. So there's private. The same way that private is not visible outside this contract, it also applies to the state variable. So it's not visible outside this contract. We have internal, we have private, and we also have public. Those are the different, but by default, it's always in internal. So that's all about internal, external, and private. So now, let me show you one thing again. This is very useful, especially when you want to have something in your code that cannot be changed. Let me try to say unit constant A is equal to 100. See this line of code now, there's no way for you to change this A because this A is constant. It cannot be modified. Let me prove that to you. Function change A. So this change A is equal to, let me make it public. What this change A is trying to do is trying to change A to 50. It's going to throw error. You know why? Cannot assign to a constant variable. So once a constant variable has been declared, you cannot change it. It's going to be there forever and ever. There is no way to change the value of a constant variable. So it's always very useful. Maybe you want to have something that does not change your smart contract. So you can just make it constant. There's another way again. You can also have immutable. You can also see that when you add immutable now, it's almost the same result that, okay, cannot write to immutable variable, can only be initialized inline or assigned directly in a constructor. So immutable and this thing is different in the sense that immutable can be changed only once and can only be changed inside a constructor. Or when you are declaring it. So when I was declaring that, I automatically assigned 100 to it. But if I don't assign anything, it's not going to complain. You can see that it's not complaining. It's still working. So I can initialize it just one time inside the constructor. But if you have a constant like this, let me say constant, you see, it's complaining. You have to initialize constant by default. So if you don't initialize, it's going to complain. So that's the difference between constant and immutable. How do you now assign a value to an immutable? It's by using a constructor. Let me show you what a constructor does. This is a constructor in Solidity, and you can see that you can have A is equal to 50 here. Oh, sorry, immutable. Sorry, we didn't change it. So it's immutable now, and it can assign value to it from this constructor. But if you try to assign value from it, value to it from any other place apart from the constructor, sorry. Yes, it works for all data. It works for all data. Okay, so let's continue. It works for all data. So let's continue, and we can have A is equal to 50 here. It will work. But if you try to assign A is equal to 50 somewhere else, maybe inside a function, it's going to throw error. The only time you can assign to an immutable is when you do it inside a constructor or inline. So that's it. If you don't do it inline or you don't use the constructor, it's going to throw error. So what's this constructor all about? This constructor allows you to initialize some values in your code when you are deploying it. Let's assume you want to store the name. Maybe you are creating a token. Let's just name this thing to a token. Sorry. When you are creating a token, and what we want to do is that we want to have the name of our token. But one thing is that you know that the name of the token should not change. It should not change. So it's immutable. It's not a constant because we want anyone deploying this smart contract to be able to choose their name. That's why they don't make it constant. So this is constant. If you make it a constant now, it's going to require us to give the name of the token by default. So BKN, or let me name it. Sorry, let's have a string. Sorry, not it's a string. Let's have maybe BIH token. So that's the name of the token. We can now say string constant symbol is equal to BIHT. So that's the name of our token, and that's the symbol. So now for this token, what we want to do is we want to deploy it. If you deploy this token now, it's going to be there public. Let's make it public. So it's public and it's constant, and everything is just there. Let's try to deploy this contract. Let's try to deploy. So the moment you deploy the contract, you can see that we have two interface, we have the name and the symbol. So when you click on name, you can see it's returning the BIHT token and also returning the BIHT symbol. So that's how it works basically. And you cannot change this name and symbol because it is constant. And however, what if we want our users to be able to choose their name when they are deploying the contract? So we can make it immutable. So let's make it immutable. It's complaining. You cannot have a non-value type. Okay. Yeah. So one thing again about immutable, sorry, I made a mistake earlier. I said it's applicable. Immutable is applicable to some data type. So this is a non-value type. It's not applicable to string like this, so it's not going to work basically. So you see, it's not going to work for something like a string. Do you get? It's not going to work for something like a string. So, but it can work for um, other things like uint 256 and the likes. Since they are just value type. They are not array and stuff like that. Okay. So it's going to work. You can see it's not working for string. Let's try to remove this and let's look at it from another perspective again. Let's assume you have a token. There are three major things or four major things you need. You need the name of the token, which is the string. Then you can say string name of the token. This is right. But I want to make the name public so that we don't need to declare name. You can also have another string public symbol or the ticker. Yeah, some people call it symbol, some people call it ticker. Symbol. You have but what other thing do we need again? Let's have the uint 256, which is the public total supply. They also have another one again, which is the what other thing should we have again? Okay, we don't have anything. Let's just have a mapping. This is a mapping of the address of all our holders to the balance that they have. To the balance they have, which is the uint 256, right? A mapping of address to uint 256, which is the balance. So these are the three things that we have on screen. We have the name of the token, the symbol, the total supply, and the balance. So now what we want to do is that anytime you are deploying this contract, you get to choose your token name. So usually you can have something like this constructor. Let's have a string memory name, then comma. You can also have string memory symbol. Then what other thing do we choose again? Let's say string uint 256 total supply. But one thing is that see, there's going to be conflicts because you cannot have the same variable names twice. We've used this name already. We've used it. So the best thing, you can just make this one underscore. What do you think? We should have underscore. We should add underscore here. Underscore, then underscore. So that those names can be unique. So name, symbol, and total supply. We have three things here. So the moment to deploy, if you come here now, let's try to deploy this contract. You will see what I'm trying to say. If you want to deploy this contract now, it will not allow you to deploy directly. You can see it's going to show error when you click on deploy. It's going to require you to input three information, which is the name, the symbol, and total supply. And that's because we are requiring three parameters, argument before we can deploy the contract. So now, anytime you have something like this, you have to find a way to use it. So this name now, how do we set the name to this name here? How do we set this symbol to this symbol here? How do we set the total supply to total supply here? We can do that in a very easy way by saying underscore name, which is this one, is equal to the name provided by the user. Then underscore symbol is equal to the symbol provided by the, is equal to symbol provided by the user. Then we also have underscore total supply is equal to the total supply provided by the user. So this one, and if you do something like this, we are good to go. We can deploy the contract again and see what we have. So let's say we have, the name is BIH, right? BIH token 2023. So we can just name it BIHT. Then total supply can be like 1,000 way, which is a very small value. It's very small. So we can transact. And once you transact, you can see that we have a new contract here with 3 methods: name, total supply, and symbol. So let's click on, you can see how the symbol is this one, the name is this, and total supply is this. So that's how it works basically. And you can further improve this contract in the sense that, how do we send money from one account to the other? Then we have a total supply. Having a total supply is not enough. We have to find a way to assign that total supply to someone by default. So when you create a token, the process of minting is assigning the some tokens to a particular account. So we can do that by saying balance. Then who is sending the message? You can do that by doing message.sender. And we are using this index, which is an address, because our mapping key is address too. So that's why it is working. If it is something like an integer or stuff, then you are expected to be using an integer. But since it is an address, then we are good to go. Then the balance of this person now will now be the total supply. That means we are sending all the total supply to this particular address. So let's do public. Let's say public for this one, so that we can also see the mapping outside the smart contract easily. Let's delete everything and let's try to deploy again. You can see that we still have those 3 info. Let's have BIH token. The name is BIHT. Then total supply is 1,000 way. Let's do transact, and you can see that we have 4 interfaces exposed on the screen. We have the balance, we have the name, we have the symbol. So if you click on name, you see this is the name, this is the symbol, and this is the total supply. So if you want to get the balance of a particular address, I'm going to deploy the smart contracts, right? It's going to automatically send all the token to me because I'm the message.sender here. Message.sender. Then if I copy it, let me copy, and let me click on address and call. So you can see it's returning 1,000 here. So that's how it works basically. And you can also write your own token from scratch. In the other class, we actually used an existing library, opposite library, to write our token. So you can see that this address has 0 because it's not the owner of this contract. So now we can also implement something like maybe send or transfer. So to transfer, we need 2 things. You need the receiver. So you need to address of the receiver or 2. Then the amount you want to send, which is unit 256. Then we can now say amount. Then we can have it public. Then what we do now is that we now take the balance of the person interacting with this contract, msd.sender, is equal to, okay, yeah, let's remove it, minus equal to the amount you are trying to send. Then what we now do is that we now add that balance to the other party, which is the receiver 2, is equal to amount. So that's how to basically remove from someone and add to the other party. So by doing this, you're actually transferring funds you are deducting from your own balance and adding it to someone else's balance. That's the logic behind transfer in most programming language. Then you can also have another thing like maybe get balance. If you don't want to use this approach of using this public interface, you can implement a custom method called get balance. So let's try this transfer and see whether it works or not. So let's delete the former one. Then we can say the name is BIH token. Then we can say BIHT. Let's have 1000 way and transact. So once you do this, you see that we have everything. We have transfer, we have everything. So the first thing we do is let's try to get the balance of this user first. Let's get the balance. You can see we have 1000. Then when we do transfer, we can do transfer from my current account to the other account. Let me copy this wallet address, switch back. So I've copied the wallet address. I can say 2. Then I want to transfer, let me transfer 900. Oh, let me transfer like 200. Okay, transfer. So I've done that. If I click on balance now, my balance is now 800. Then the balance of the receiver, which is the 2, should change to, should be 200. You can see that it is working perfectly. So that's how to build a very simple token contract. Although this might not be really secure, but it gives you basic understanding of how it works. Okay. Next thing again is let's try to see how we can work on real deposit contracts. So I'm going to copy this code and make it available on GitHub. So let me do that by going to blockchain. Sorry. Let me try to do that later. I'll do that later. Uh, let's just create a new file and see what we have. Let's name it 13 underscore fundraiser. So this fundraiser contract is a contract that allows you to raise funds from people. Anyone from anywhere can basically send you funds. So they can basically send you funds so that you can, meet your goals. So this is how we do it. The first thing we have to implement is the logic, which is, let's just name it fundraiser contract. Let's name it fundraiser contract. Then this is the first thing we have to do. We have to have a constructor. Inside this constructor, you can specify your goal and other stuff. So we have to have a state variable that will store our goal. So the goal is dynamic. It can change. So you can say uint256 goal underscore add underscore to the end so that it will be different from this goal. Let's make it immutable for transparency, because what this immutable means is that the moment we deploy our smart contract, we cannot change our goal again, and it's going to give our users confidence that okay, we cannot change the goal later on. So what we want to do is let's just have the immutable version. So goal is equal to this goal with underscore, and that's all. And the next thing is who is receiving the money in 256. You can say, sorry, address of the owner. So address of the owner should be visible here. That you can just say comma and say address owner. Or better still, if you don't want to do that, you can say owner is equal to message.sender. So anyone that deploys the smart contract becomes the owner automatically. Do you get the approach? So since this owner will be receiving funds, you can make it payable. You can say payable owner. That's where it comes from. You can say there's an error. I mentioned something yesterday that address is not implicitly convertible to address payable, but it is possible vice versa. You can convert address payable to address implicitly, but not the other way around. You cannot convert address to address payable implicitly. You have to make it explicit. To make it explicit, you can come here and cut this and say payable. Then wrap this message or sender inside it to make it become a payable address. So now that we are done, the next thing is deposits.
Hello,
What I want to
Oracle,
do is I
please.
want to receive
Hello, sir.
data. Hello?
Hello. Yes, before you go to the next
Yeah, I'm
thing,
with you.
please slow down a bit for those of us following. And secondly, I have a question concerning the immutable goal. Mine is bringing an error. That immutable, because it's not initialized. And I
Okay, what
think
error
you
are you
explained that
getting?
we don't need to initialize it. The immutable. Yeah, when I
Okay.
put
What error are you
the
getting?
semicolon, is like red, squiggly, red.
Oh, okay. Can you share the screenshot with us on the WhatsApp group so we can rectify? Okay, I can check that for you. Yeah. So thank you. Yeah. So we have the immutable goal, and you can also see that we have uh, this deposit function. So it is a public function because anyone outside the contract can have access to the deposit code, and we can also have we can have the
All right.
we can have the
You can go ahead.
this
Or you can go ahead.
okay, yeah, thank you. So we can make this one payable. The main reason I'm making this deposit payable is because we want to receive ether. We want to receive ether whenever we call this function, and this is what we want to do. Anytime someone deposits money, this is okay. Let me show you how this code works first. It's better to see it practically than to just explain the theoretical this thing. So let's now try to deploy this contract. Let's set our goal to 1,000 and transact. Once we transact, everything is working, and you can see that this function is red. It's red because it is payable. Let me click on deposit. It's going to work, and you can see that my ether is still 0. The ether in this contract is 0. The moment I come here and maybe I try to write 1,000 way, or maybe let me try to change it to maybe 1 ether. So I've changed to 1 ether and I click on deposit here. You can see that it's removed 1 ether from this account and transferred it to the smart contract. And this is possible only because of this payable function. So once you make a function payable, it automatically allow you to send value with it whenever you are calling the function, and the value goes to the smart contract. So it's just like transferring funds from your own account to the smart contract account. So that's how it works. And next thing is, how do you now know how much that we have raised so far? You can also have another variable that keep tracks of that. Let me say this one is not immutable because it's going to change. Let's say progress. So this progress is going to track how much that we have raised. How do you now track it? I did something a few classes ago regarding message.value. So if you want to know the amount sent with this call, with this function call, it's going to be provided by the message.value global variable. So by doing that, I can say that, okay, the progress that we've made is equal to the last progress that we've made so far plus the current message.value. But one thing is that this code is too long. We can just use the shorthand version of this, which allows us to see this. So we can now add public to this progress so that we can see how far we've gone. Let's add public to all these state variables. You can so that we can see it easily from outside the contract. Let's delete this and let's try to set our goal to 1,000 and transact. Once we transact, you can see that we have three interface there. We have one for the goal. Once you click on the goal, you can see 1,000. Progress 0. So let's now deposit. Let's deposit 1 ether. Let's move down and click on deposit. You can see that if you click on this, the progress now, you can see that it is 1 ether, which is a very long string of number, like 18 digits. Is 18 digits. Sorry, 1 followed by 18 digits, yeah. So this is our progress so far, and that's because anytime we send value, we append that value to the former progress that we've made. So that's how it is possible. Let's try to send another 1 ether again. Or let me try to send 5 ether. So I'm sending 5 ether this time around. I'll click on deposit, then click on progress. You can see that we have 6 ether in this contract, and the progress is 6 ether. Yeah, this is very sweet and it's very easy to understand. But also, please take note that whenever you send money to a smart contract, there won't be any way for you to retrieve that fund except you specify a way to withdraw it. Your funds can be locked in a smart contract forever if you write the wrong code. It has happened in the past. Some people they have thousands of dollars of NFT in their smart contract, but they were not able to retrieve it because there is no logic for them to retrieve it in their smart contract. So smart contract is all about logic. There's no private key. It's all about logic. If there's no logic for you to withdraw, you can only deposit but not withdraw. So your funds will be locked forever and ever. So now let's now have a logic to withdraw. Function withdraw. So once you have this function withdraw, it's going to be public. It's not going to be a payable function because we are not sending any value with it. It's not coming. The value is not coming from EOA. It's going to you, so you don't need to make it payable. It's not coming from EOA or other smart contracts, so it's not going to be payable. And you can have it like this. How do you now do the transfer? You can say owner dot transfer. Then how do you now know the balance of this smart contract? Like all the money inside this smart contract. When you click on withdraw, it should send it. Actually, you can set a value that okay, should withdraw 100, but this can lead to a security problem because if the money or the fund in the smart contract is not up to 100, it's going to fail. So the best thing you can do is just to make sure that you withdraw all the funds available in the smart contract as of that moment, which is by doing owner dot balance. You can say address of, let's say, address of this smart contract dot balance. So this is how to get the balance of this current smart contract. So if you do something like this, address of this is going to return the address of this smart contract and print it on screen. Let's try and prove it. Function get my address. If you do something like get my address now, and you say public view returns address, right? Then you can say return. Oh, sorry, we missed one policy. Return address. Do you see? This is how it works, basically. So now, get my address is very easy. And if you deploy it now, when you click on it, it's going to return the address of this contract, address of this. Then when you know the address of a particular EOA or SCA, you can easily query their ether balance by saying that address dot address of this dot balance. Okay. So it's going to return the balance and it's going to transfer the balance to you. So let's deploy this contract and see what we have. Let's say our goal is something very big this time around. We transact, we will scroll down, we say goal. You can see this is our goal. Our progress is still 0. Let's try to deposit. Deposited 0 is still what? Progress is still 0. Let's try to deposit 1 ether. So if you click on 1 ether and click on deposit, the balance of this contract is now 1 ether. And if you click on progress, you can see that our progress is 1 ether too. Let's click on withdraw. Can you see that the moment you click on withdraw, the balance goes back to 0, and all the fund has been sent back to the owner, which is this account. So you can let's try to do something. Let's try to send deposit like 100, 1,000. Oh, sorry, that's too much. 50 ether. Let's deposit 50 ether. Then you can see our progress. You can see our progress is still large. So you click on withdraw. So let's go and check the balance now. You can see the balance is 42, right? Of this account is 42.99. Then the balance in the smart contract is 50. If you click on withdraw, it's going to withdraw all the fund in the smart contract and send it back to this address. You can see it's back to 92. That's how it works basically. The logic behind the withdraw this thing, that's how it works. And it's very easy for you to introduce vulnerabilities into your code. First of all, do you want to write a smart contract that automatically resets whenever there is withdraw? Maybe it reset the goal back to 0 or stuff like that. And also maybe just make sure that you think very well before you write the smart contract. Then let's check something again. If you click on get my address, you can see that the address it returns matches with what we have here. Let me copy it. I've copied the address. You can see that the address here matches with what we have here. The address returns matches with what we have from the smart contract. So that's how it works basically, and it's straightforward and simple. Okay, so that's how it works basically, and right now we are open to questions and also contributions from everyone on this call. If you have any question, please unmute and ask so that we can address it ASAP. Okay, if you have any question, please you can ask so that we can unmute you.
All right, Oracle, thank you so much. I want you to please explain the concept of require when it comes to conditional statements.
Okay, so we've not gotten to require actually, and that's why our smart contract is still messy. If you look at it, you feel like, oh, there should be some check. There should be, okay, how do we check if this person actually have the money they are trying to send and stuff like that? So these are one of these require can help us with. When you use require and the condition is true, your code will not revert, but condition in the require is false, it will revert, and also you can provide an error message in the revert in the require field. You can just put the condition, which is going to be the first argument, then second argument is going to be the error message. So that's how it works. So, but we've not gotten to require. That's why our code is a bit messy, and we won't want to move too fast. So please when you have enough time, you can just go through the smart contract again and look at ways you can implement your own contracts and also do stuff. Then now the next thing now is let's try to do one more thing. Okay. Yeah, any other question? So let's try to work on the function selector now, and let's see what we can do with the function. Let's just have 14 underscore function selector. You don't actually need this function selector like that, except you are coding something to advance or stuff like that. So, but now you might not really use it. So, but it's still good to know it. There's no knowledge is ever wasted. So let's have This is our function selector, then you can name it function selector example, right? So this is it. And you can see that in this function selector example, we have a function, and in this function now, okay, you have to use two contracts to demonstrate this. We can't use a single contract to demonstrate it. Let's use two contracts. Let's name it function selector example 1 and function selector example 2. So this is a function, and the name of this function is called add. Yeah, let's say add in 256 a comma in 256 b. Okay, external. Let's just make it public for now. And once you make it public, you can say return a plus b. Then you can say returns u in 256. Okay, it's a view function. It's a pure function because it's not taking anything. Okay. Okay, that's this function. Let's name this function mathematics or mass. Yeah. Let's name this contract mass contract, and this one function selector example, so that we can understand it better. So we have two contracts in this file. We have math and we have function selector example. So the main principle of this function selector is that for you to calculate a function selector, you have to get the first 4 bytes of the KCAC 256 of the function signature. So you can say function selector of this. So function selector. Say public. Let's say get function selector. Let's just name it get function selector. So this is the name of the function, and once you get the function selector, return the KCAC 256. This KCAC 256 now is going to take something like ABI encoded this thing. Don't worry about this ABI encoded what's it called? This ABI encoded with signature. Sometimes just API dot encoded with signature. So that's just like very simple method I can call to encode a particular string. So it's let's now say what's the function signature of this guy here? The function signature should be something like this. Add in 256, comma in 256. Then that's the function signature. Let's copy this and bring it here. Okay. Oh, sorry. So there was a mix-up. It should be like this. Sorry, not the other way around. Let's remove this KCAC 256. Blah blah. So this is how it's meant to be. Sorry for that. So you can say return because it's going to return byte 4. And I told you already that the function selector is actually byte 4. So that's what it's going to return. It's going to return byte 4. So But KCAL 256 by default returns byte 32. So this is what I want to do. You can see byte A. So you can see byte 32A, KCAL 256. So once you have this ready, this is going to be 32 bytes. You can now see, you can convert this by 32 to byte 4 by saying byte 4 of this A. So it's going to return this KCAL 256 as it's going to be pure function. So it's going to return it as a byte 4 instead of this byte 32. It's going to truncate it to byte 32. So let's just try and deploy this to contract and see what we have. So let's come here and deploy. The moment to deploy this contract, you see we deployed just the first one, which is the function selector contract. We've not deployed this math contract yet. When you click on it, you can see that there's a byte 4. And this byte 4 return value is the function selector for this add A, comma B here. So how does it work? Let's do something like this. Let's try to deploy this A. When you deploy, you can see that you have this guy A and B, which you can add together, which is going to give you 3. So now with the function selector, you can actually call the function directly without having to interact with the smart contract from outside Remix. So this is what you do: function call function or something like that. You can now have the byte 4 of the function selector, which is the function selector, comma, then this A and B here, because they're going to be parameters, right? So then you can have public pure returns what? It's going to return integer, right? Which is doing 256. Uint 256. So this uint 256 is here, and you can say you can now do something like, okay, so also you need the address you want to interact with, address of this smart contract. So you can just say something like address smart contract, which is SA or something like that. So you can say SA.call. So this dot call now, you can have it. Then what do you want to call? You have to put the function selector, you have to put the parameters and every other thing that you need to you can say ABI.encode with signature, then the function selector here, comma, and the value. So you can say ABI.encode with signature. So that signature is going to be the signature of the function I want to call. This is a function, and this is going to be the parameters or the argument. Sorry, A, comma, B. Are we getting any error? Okay? This is okay. The return type. We have 2 return type. It's going to return 2 values. It's going to return whether it is successful, and it's also going to return the return data. So you can say bool success, comma, then byte 32 memory, then I want to check the data or something. Can just say data or something, or return data. Let's say return data, which is equal to this. Then wrap this one inside this code. This one is bringing error. So data can only be mapped for structure, but memory was given. Sorry, it's still what I'm showing error. Let's try to. Data location can. Oh, sorry, it's meant to be bytes, not byte 32. That's the problem. Then this function selector, okay, invalid type from string memory. Okay, okay. Yeah. So this one is going to be string, not the string. Let's say string memory. Then we have the function selector. We are running into errors every time. Let's check this. Okay. Okay, function cannot be pure because it modifies something. Let's remove the pure function, and we are good. Let's now say return this return data here. Then since we are returning byte memory, we cannot have the return type as in256 again. So with this we are good. We are not using this success, so let's just have it there. We are not using it, but let's have it there. And let's try to deploy this contract again. So I'm coming. So let me try to deploy again. So you have to switch so that to make sure that you are deploying the right contract. So yeah, let me deploy. Once I deploy, I can see this third function here with the get function selector. This is the function selector. Then also there are tons of parameter that I have to input. The first one is the smart contract address. This is the address I want to interact with, the address of the math contract. So let me copy the math contract. Then the function selector I want to interact with. Let me copy this. You can see that this is the value here. So let me paste it. The next thing is the value 1 and 2, then transact. So the transaction went through, and you can see that there is a success message here. So for us to now get the value that was returned, which is the byte, what byte did it return? The return data byte, yeah, byte memory. So we can just come here and check the console log. So you can see inside the decoded output, you can see that there's byte, and the answer is 3. The answer is 3, yes. So that's how to use a function selector. And although it's a bit complex, but don't worry, as you move on, you might find it useful. But you don't really need this function selector to build simple applications. But you just have to know that there's called a function selector, and this is how to use it. So if you want to do anything like maybe 10, 100, transact 100 plus 2. So if you come here now, check the log, scroll down, you can see that it is giving you 100 plus 2, which is 66 in hexadecimal value. So if you take this 66 and convert it to decimal from hexadecimal, you're going to get 102. That's one thing about this value. So the value is always in hexadecimal. So that's it. And that's how it works basically. So don't need to worry about this function selector for now, but just have to know that there's something called a function selector. The function signature is the same thing as an interface. Okay. Interface also have other stuff like the what's it called, the visibility and stuff like that. So it's not the same actually. So yeah. Hope I was able to answer your question, Moyo. Any other question regarding this function selector? Okay, so let me now chip in the last stuff for today. This thing is also equivalent to doing something like this. You see the way we did our own, we added ABI dot encoded with signature, then we added the function selector A, comma B. You can also use encode, sorry, with selector, yeah. Let me try to remove this so that it can hint me. Where dot encode with selector, you can see this function. So this one is going to be byte 4. So this byte 4 is something you can use with this encoded with selector. So byte 4, so you can bring it here, then put all the arguments, which is A, comma B. So you can have it in the call function. And let's scroll down. Let's remove this contract and let's deploy it again. If you deploy it now, you can see that we have the same thing, but this time around it's just this byte 4, sorry. So let's get the function selector. I've gotten the function selector and I'll replace this byte 4 with the function selector. The smart contract address you want to interact with, the parameter I want to pass to it, then transact, so it should work. So it's almost the same thing as what we have earlier, but this time around we are not passing string, we are passing the function selector directly. So you can scroll down to the decoded output. You can see that the answer is 14. 14 in hexadecimal is 20 in decimal. So that's how it works basically. So you can also use this approach. And also, since there's function overloading in Solidity, let's try to do something like this. Let's copy this code. Then let's undo. So once you undo, you can have this same function in 2 places. One that takes in byte 4 and one that takes in the function selector as a string. So that's how it works. I'm going to make this code available on GitHub by the end of this class. So thank you. Yeah, any other question? Please feel free to ask questions on the Arbitrum WhatsApp group. So we're always available to answer your questions. Bye-bye. So since there's no question, I have to call it a day.